Good morning, dear students. As we studied in our last lecture regarding the methods of expressing the concentration of solution, we have studied different methods, and one assignment was there, 1 molar aqueous or 1 molar aqueous solution which is more concentrated. So as we know, 1 molar means 1 mole of solute has been dissolved in 1 liter of solution, and 1 molar means 1 mole of solute has been dissolved in 1000 gram of solvent. As the solvent is water here, we are talking about the aqueous solution, and we know that the density of water is 1 gram per centimeter cube, or you can say the density of water is 1 gram per ml. So from that we can say that in case of 1 molar aqueous solution, we will have 1 mole of solute in 1 liter of solution. Whereas in this case, 1 mole of solute is present in 1 liter of solvent. How we can say that? As the density of water is 1 gram per ml, so 1000 ml equivalent to 1000 gram. So here 1 mole of solute is present in 1000 ml of solvent, or you can say 1 mole of solute is present in 1 liter of solvent. So in this case we are having more quantity of solvent as compared to 1 molar aqueous solution. So that's why we will say here 1 molar aqueous solution is more concentrated as compared to 1 molar aqueous solution. Now moving on to the next topic. The next topic is chemical potential. We are very familiar with this term, chemical potential. What do we mean by chemical potential? How we can define this? Chemical potential is the increase in free energy at constant temperature and pressure when we add 1 mole of a constituent to the system, keeping the amount of all other constituents constant. Means chemical potential is the increase in free energy when we are adding 1 mole of constituent to the system. Conditions are constant temperature and pressure, and the amount of all other constituents is constant. Mathematically, we can express it: mu is equal to curly G by curly Ni at constant temperature, pressure, and composition of all other constituents. Now next one is vapor pressure. What do we mean by vapor pressure of a liquid? For this, we can consider a beaker containing pure liquid is covered with a jar. Now what you will observe, some molecule on the liquid surface, they are getting evaporated and fill the vacant space available to them. Similarly, the molecules in the vapor phase, they move randomly in all directions, and during their motion they are colliding or striking with the surface of liquid and getting condensed. So the process of this evaporation and condensation, that is continuously going on, and an equilibrium is established between evaporation and condensation ultimately. Now the pressure exerted by vapors over the liquid surface at this equilibrium, when we are having there is equilibrium between evaporation and condensation, that will be known as vapor pressure of the liquid. So how we can define the vapor pressure of liquid? It is the pressure exerted by vapors over the liquid surface at equilibrium, that is known as the vapor pressure of the given liquid. Now from the figure you can see, when we are having pure solvent and when we are having a solution, what is the difference in the vapor pressure? What change we are observing when we are adding solute to a pure solvent? So what we are observing here, because of solute-solvent interaction, the non-volatile solute, they are making it harder for the solvent to escape to the vapor phase. Means the tendency of solvent molecule to escape to the vapor phase decreases in the presence of solute. Because of that, the vapor pressure of solution would be lower than that of the pure solvent. So vapor pressure of a solution will be lower than that of a pure solvent. We can see from this figure also the vapor pressure is lower when the solute is present, whereas in case of pure solvent we are having high vapor pressure. Now we will discuss about Raoult's law, which is very common. We have already studied during your 10+1 and 10+2 regarding the Raoult's law. Now from what we get the Raoult's law, how we can define this? In 1986, a French chemist named F.M. Raoult, he proposed a quantitative relation between partial pressure and the mole fraction of components of the solution. So what was the relation between partial pressure and mole fraction of components of the solution that was proposed by Raoult? According to Raoult's law, what it states, in a solution, the vapor pressure of a component at a given temperature is equal to the mole fraction of that component in the solution multiplied by the vapor pressure of that component in pure state. The vapor pressure of solution will be given by product of mole fraction of the component and the vapor pressure of that component in the pure state. Now, if we are having both the components volatile, the total vapor pressure of a solution containing two components A and B is Pa is equal to P naught A into XA. This is according to Raoult's law. The vapor pressure of a component in a solution is equal to vapor pressure of pure component and the product with mole fraction of that component in the solution. Similarly, Pb will be equal to P naught B into Xb. So the total pressure of the solution will be equal to P naught A XA plus P naught B XB. Now we very well know that the summation of mole fraction is equal to 1. So XA will be equal to 1 minus XB. So from this we can get total vapor pressure will be equal to 1 minus XB into PA naught plus PB naught XB. And finally, we are come up with the relation P is equal to, where P is the total vapor pressure of solution, that will be equal to P naught B minus P naught A into XB plus PA naught. This is the expression when we are having both the components volatile in nature.